You ever just look at a map and think, yep, that's what the world looks like? Well, what if I told you that's not quite right? Today, we're going to pull back the curtain on cartography. We're going to deconstruct the very maps we see and trust every single day.
Let's kick things off with this incredible thought from cartographer Marc Monmonier. He basically says a map isn't just a picture of the world. Nope. It's an authored collection of information. Think about that. It's a story. And just like any story, the storyteller, the map maker, gets to decide what you see, what gets emphasized, and what gets left out.
And that leads us to the big idea, the main takeaway for this whole thing. Every single map is a lie. Whoa, okay, I know that sounds dramatic, right? But it's not always a bad lie, it's a necessary one. See, distortion isn't some mistake a cartographer makes. It's actually a fundamental part of making a map in the first place. Let's dig into why.
Okay, so to really get this, we've got to talk about the one map we all know. The one that was probably hanging on your classroom wall, right? I'm talking about the Mercator projection. This map is like the poster child for this whole beautiful necessary lie thing. So this Mercator map, it was made way back in the 16th century. And for what it was built for, it was genius, pure genius. Its whole purpose was navigation. Sailors could just draw a straight line from point A to point B and follow that compass bearing. Simple. But, and this is a huge but, when it comes to showing how big countries actually are, oh boy, that's where it all falls apart. Like, spectacularly. And this is the perfect example. Just look at this. On the map we all know, Greenland looks absolutely massive. You'd think it's about the same size as Africa, right? Well, in reality, Africa is 14 times bigger. Let that sink in. 14! What the Mercator projection does is it just stretches everything out like crazy the closer you get to the poles. It gives us a totally warped view of our own planet. So you're probably thinking, okay, if it's so wrong, why on earth did we use it for so long? And that's a great question. The answer gets to the heart of what map making is all about. You see, every map has to choose what to be honest about. It can't be honest about everything. The Mercator map chose to be honest about direction and sacrificed honesty about size. And that trade-off, well, that's the fundamental problem every map maker faces.
And this core problem has a really simple, kind of perfect name, the orange peel problem. Seriously, this is the one thing that every single cartographer, no matter how skilled, has to wrestle with.
Just picture this right now. You've got an orange. You peel it in one piece, which, let's be honest, is already impressive. Now try to lay that peel down flat on a table without it ripping or stretching or tearing. You can't do it, right? It's impossible. Well, that's exactly the challenge of putting a round planet onto a flat map. So you've got the Earth, which is basically a ball. A slightly squashed ball, technically, but still a ball. And then you've got a map, which is a flat sheet of paper. There's just no way to get that round surface onto the flat one perfectly. It's physically impossible. Something's got to give. You either mess up the size, the shape, the distance, or the direction. You have to pick your poison.
And that whole process of translating the globe to a flat surface, that's called a map projection. The key word here, though, is compromise. Every single projection is a choice. The map maker has to sit down and decide, okay, what's most important for this map? What am I willing to sacrifice to get it? It all depends on what the map is for.
Okay, so distorting the shape of the Earth is one thing, but that's just the beginning. The lies in a map can get way more subtle. Let's shift gears now from the geography itself to the data we layer on top of it. Because how you group that information, well, that can tell two completely different stories. To show you what I mean, we're going to look at a type of map I guarantee you've seen a million times, even if you don't know its name. It's called a choropleth map. It's basically any map where different areas are colored in to show you some data. Think about election maps with red and blue states, or maps showing population density. Yeah, that's a choropleth map. All right, now this is where it gets a little sneaky and really, really fascinating. You can have data that is 100% accurate, completely factual. No one's arguing with the numbers, and yet a map maker can use that exact same data to create two maps that lead you to totally opposite conclusions. How? It's all about how they decide to group the numbers. So let's play this out. Let's imagine we've got some unemployment data for 10 different counties. The numbers range from a pretty low 2% all the way up to 12%. These numbers are just numbers. They're neutral facts. But watch what happens when a cartographer gets their hands on them. All right, here's story number one. The mapmaker decides to group the data like this. Anyone with unemployment from 0 to 8% gets put in the low category, the lightest color. And bam, look at the map. It's mostly light, happy colors. The story this map tells is, hey, this region is doing great, broad prosperity. Everything looks pretty rosy. But wait, let's take the exact same numbers and just slice them up differently. This time, we'll make the categories smaller. Let's say 0 to 4% is good, 4 to 7 is okay, and anything over 7% is bad. All of a sudden, the map is filled with dark, scary colors. The story has done a complete 180. Now it's a region of rising concern. It's the same data, folks, just a different story.
Okay, so we have shape distortion and data distortion. Wild, right? But there's one more layer to this, and this one is all about us. It's about the distortion that happens right inside our own heads. The way a map uses simple symbols can actually trick our brains without us even realizing it.
Yeah, there's actually a scientific name for this, the psychophysical power law. Sounds super complicated, I know, but the basic idea is pretty simple. It just means that when we see something, our brain doesn't always process it in a perfectly linear way. And this gets really weird when we're trying to compare the size of shapes, especially circles, on a map. Here's how it messes with us. Imagine a map shows a big circle for a city of 2 million people. The area of that circle is exactly double the area of a circle for a city with 1 million people. Make sense? But here's the crazy part. Your brain doesn't see it as double. You'll probably look at it and perceive it as maybe 1.5 times bigger. You naturally underestimate it. So the map's message gets watered down somewhere between the page and your brain. So let's recap. Maps can distort geography, they can manipulate data, and they can even trick our own brains. Wow. It kind of sounds like we should just give up on maps altogether, right? But no, that's not the point at all. The goal isn't to find some mythical, perfect map that doesn't lie. It doesn't exist. The real goal is for us to become smarter, more critical readers of every map we see. So from now on, whenever you look at a map, don't just soak it in passively. You got to become a detective. Ask yourself some simple questions. First, who made this map, and what were they trying to achieve? What projection are they using, and what is it stretching or shrinking? How do they decide to group the data, and what are these colors and symbols supposed to make me feel?
And this brings us full circle, right back to Marc Monmonier. He argues that the answer to a biased map isn't to go hunting for a single, perfect, unbiased one. The real ethical solution? It's to look at more maps. Look at the same area with different projections. Look at the same data classified in different ways. The more perspectives you see, the closer you get to the truth.
So here's the bottom line. A map is never just a map. It's not just a tool to find out where to go. It's an argument, it's a story, it is a very specific point of view. So the next time you look at a map, don't just ask where. Go deeper. Ask why. Why does it look this way?